You'll give them a try. And these are like real world kind of situations here. Okay. Okay. Here we go. Okay. Let's see. Let's see. Okay. Let's. Okay. And one of the things we study in public health is public health emergencies. And with Halloween coming up, we know that zombies are like a real issue. We have to be concerned about zombie epidemics of mindless, reanimated human corpses. With a hunger for human flesh appearing. So we're gonna do a little calculation involving zombies and confidence intervals. Their primary food source is brains and spinal cords. Therefore, their serum cholesterol levels are outrageous. So we sampled 25. We randomly sampled 25 adult zombies, and we found that the mean serum cholesterol was 151.4, and the population standard deviation, sigma, sigma in this case, is assumed to be the same as for living humans, which is 38. Okay, so calculate the standard error for zombie cholesterol and calculate the 95 and 99% confidence intervals for the mean cholesterol for all zombies. Okay, what do we know? We know our sample size, we know X bar, our sample mean, and we know the population standard deviation, or what we're assuming to be the population standard deviation. So do we need a t-table on this one? No. Okay, good. You guys calculate it. Okay, you guys at home, maybe you want to work on this too. I'll give you a few minutes to work on that. Let me just blank out my screen here. I'll do it in the background here. I'll pause this. Okay, don't panic online there. I'm just pausing it so I can work it out while I'll work out the answers myself while you guys are working as well. What do I have there? As far as the 54. So even though this is a small sample, you can still use the z-score, right? Because you know the population standard deviation. Okay, and what was the other one here? Okay, so that's for there. 90. Okay, and give you another second. Okay, I'll turn my screen back on. Okay, guys, this is what I got. Let's see if we got the same answers here. Okay, first thing I did was calculate my standard error. Going to be equal to my standard deviation for my population, which was 38, divided by the square root of the sample size, which was 5. Okay, I got 7.6 for my standard error. Then I calculated for my 90% confidence interval. I said I'm going to use the z-score since I know the population standard deviation. So I said 154.1 plus or minus my, what is this called again? 1.9697.6 margin of error, right? And that came out to be 14.9 roughly. I added and subtracted that from the mean, plus or minus. Okay, and I got 136.5 to 166.3. So that's my 95% confidence interval for the true cholesterol level for zombies. Okay, and if I look at, if I wanted a 99% confidence interval, I used 2.58 for my z-score, right? Because that's what I got for my z-table. And I got for an alpha over 2 of not 1%, but 0.05%, half a percent. I got 131.8 and 171. As expected, my 99% confidence interval is wider than my 95% confidence interval. Hence my justification for being more confident that I'll capture the true mean between those two numbers. It's wider, so I got a better chance of capturing the true mean. I have a higher level of confidence. Okay, let's try the next problem. Okay, you guys again on your own. And let me read it. Careful study Living Dead movies. It appears zombies are predominantly male. College graduates, you can see one walking there. That you may have. I think he was before Levi. I think he was the previous teacher for PH751. That's what happens when you've been here for a few years. That's what happens to you. Based on a careful study, it appears that prominently male college graduates, the proportion of male college graduates in general population is known to be about 48%. I made that number up. I don't know if that's true or not. A random sample of 100 zombies from Halloween weekend zombie movie marathons, we found that 58 of this sample of 100 were male college graduates. What is a 95% confidence interval for true proportion of male zombies in all zombie movies? Okay, so let's calculate that. Let's calculate a 95% confidence interval for the true proportion of male zombies, okay, based on that sample. So what's our proportion of zombies? What's our p cap for a sample? We got 58 out of 100, so our p cap is 0.58, right? 58%. Okay. Okay, you guys online doing okay there? Can you still hear us? Okay. Okay, good. You followed that last? Okay, good. Excellent. So why don't you give it this one a try as well? Oh, it stays up. How come it didn't stop? All this time I've been saying to myself, it disappears, but it doesn't disappear. Oh, maybe it doesn't change. Is that what happens? You don't see me writing? Or can you see me writing? No, it stays the same. Okay, it just doesn't disappear. Okay. P cap. Orientation. Bless you. 9. 1068. Okay. You can't see it because I blanked out. I'm not showing you my screen, so you could do it on your own. Sample size was, I think we said 100, 58. Did we say 100? Yep. Remember, so you guys, that's part of the remember that's part of what you have to do. You have to parse these problems. You have to dissect these problems so you can pull out the right numbers from them, and that's part of what you have to do. So 100 random sample of 100 zombies. 100 zombies. That's sample size. 58 of them were male. So the proportion that were male, the p cap was 58 out of 100 or 0.58. right? And then so you have 0.58. Now you can calculate your standard error. And then you can calculate your margin of error, and then you can add and subtract it from your point estimate, right? What we called our P cap or our X bar. And that gives you your confidence interval. I'll show it to you in a second. You guys continue to work on it. I'll give you another minute. Okay, I'm going to bring my screen back up. Okay, hopefully it'll change. Yep, there you go. Okay, so let's see what these are my calculations, see if they match with yours. Our population proportion that we're male, our sample proportion that we're male is 0.58, 58%. Our sample size was 100. Calculate my standard error is going to be equal to the square root of P, which is 0.58, times 1 minus P, which is 0.42, over 100. Take the square root of that, and it comes out to 0.049, about 4.9%. Okay, so now I have to calculate my confidence interval, my margin of error, my confidence interval. My margin of error, I'm going to use 1.96. Now remember, when we're dealing with proportions, we're always going to have at least a sample size of 30, right? Because we're going to insist on having at least 15 in each of the two groups that we have. In this case, 58 zombies were male, 42 zombies were female. So we have more than 15 in each side of that proportion. Okay, so I'm going to use the z-score instead of using the t-score for this. So see, my proportion is going to be 0.58. My margin of error is going to be 1.96 times 0.049, my standard error, and that comes out to be 0.097, about 9.7%. So I'm going to add 9.7%, 0.097 and subtract it from 0.58 to get my confidence interval. So that's going to be 0.483 to 0.677. So what am I saying? I'm 95% confident based on my sample that the true proportion of male zombies is between 48.3 and 67.7%, between 0.483 and 0.677. Okay, so what does that do for what our, how does that help our prediction here? Based on this, can you say with 95% confidence that there's a difference in the gender distribution of zombies versus the living? Well, what was the percentage of males in the general population that we knew to be general population? Was 0.48. So let's think about this. We are 100% confident that the general population, the proportion of males, is 0.48. That's by definition, by what we said, by how we define this problem. And we're 95% sure that the proportion of male zombies is between 0.483 and 0.677. Are we 95% certain that there is a larger proportion of male zombies than there is a proportion of males living? I say yes, right? Because the value we're comparing it to, that we know with 100% certainty, is outside of our confidence interval. Okay, this doesn't work so well if you don't have 100% confidence in that value, right? But for our purposes, since we're saying we know what the average it's from the census, we know exactly what the proportions of males are in the United States. We can compare it to our confidence interval. Okay, how about this? How about a thought problem? I'm not going to ask you to solve it now, but based on this, right? Based on this finding, do you think you're going to be able to say with 99% confidence that there's a difference in the gender distributions for zombies and the living? No, I see a lot of people shaking their head. No, why? What's going to happen when you take the 99? It's going to be wider, and it's so close already. We know that if it gets any wider, then that not 48% is going to be inside of our confidence interval, so we can't say with 95% certainty that it's different than the proportion for zombies. Okay, so it's pretty easy, right? right? Not